All right, from our sheet, your sheet actually looked like this. From this sheet though, number one has this motorcycle and the rider is 220 kilograms, making a loop-to-loop, so it kind of looked like this in the diagram. The bike and the rider are going upside down, they're at the very top, and we're looking for the minimum speed to ensure that it's supposed to say the rider does not fall away from the top of the circular ramp. Looking at that diagram, if I kind of just redraw this a little bit, if I say that the rider is right here, when they're at the highest point here, they're going to have force of gravity pulling them down, but they're also going to have the normal force pulling them down. And this one might be just a little bit tricky. If you can imagine as they go around in the circle like this, when they're over here somewhere, normal force is going to be up this way. As they start to come around the circle, you can kind of start to see the normal force is going to point in this way. As they come over here, the normal force is going to point this way, then this way. Eventually, the normal force is going to point straight down. The normal force is the surface pushing it onto the bike. In this case, it's actually preventing the bike from flying off the circle outwards. Okay, so that's going to seem a little bit weird. You can kind of imagine if I had an eraser in my hand, if you have to kind of imagine this is one I would often do in class, but if I had an eraser on my hand and I flipped my hand around in a circle like this and went over really, really quickly like that, the eraser is not going to fall off. As my hand comes up like this, the eraser is trying to keep going up this way. It's my hand that actually pushes downwards on it to prevent that. Okay, so when you come around in a loop-to-loop like this, when you're at the top of the loop, gravity's pulling you down. The normal force is also pushing you down, I guess, preventing you from flying off outwards in this circle. When we're going at a minimum speed, trying to see like how slow can I go so that the rider doesn't fall off, what we're going to do is we're going to use circular motion. Fc is mv squared over r. And here at the highest point, as we've done in the past, if the center of the circle is here, I'm going to say towards the center of the circle is my positive direction. What that means is Fg and Fn are both in the positive direction. That equals mv squared over r. The faster I go, the more likely this thing is to fly outwards. My hand actually needs to push harder to prevent this thing from flying outwards. So the trick with this question is because it's a minimum speed, I actually have to slow down. I actually have to go slower and slower, which means as I go slower, this normal force is going to get smaller and smaller. So here's the trick. This minimum speed here means that this Fn actually goes to 0. Okay, so the faster I go, the greater Fn is going to have to be. The slower I go, the smaller Fn is going to be. Okay, so because this is minimum, this is V minimum here, this Fn actually goes to 0. What I'm left with then is mg equals mv squared over r. The rest of this question then is not very hard to do. I can cancel out my masses. I'm looking for v, the minimum speed. I know what g is and I know what r is, so gr equals v squared. If I turn this around, v squared equals 9.8 times the radius, here it is, 6.5. We're going to multiply those, we're going to square root both sides, so square root each of those things. V ends up being 7.98 meters per second. We could round that, say it's approximately 8 meters per second. Okay, so the big trick in this question is this thing right here, this normal force being 0. Knowing that, I can then move on to part B, and I'm going to try to leave part B partially undone. I'll try to get you started on it. It's very similar to this one. I'll get you started on it, and then I'm going to let you guys finish this one off. So the force exerted by the rider on the motorcycle on top of the ramp when the speed is 11. We're really starting with this exact same expression that we had over here. We could kind of start again and say that it is Fg plus Fn equals mv squared over r. Because my speed is no longer a minimum, this normal force is no longer 0. Okay, so it's 0 when V is a minimum. When V is not a minimum, this normal force isn't 0. Again, the faster I go, the greater this normal force has to become. Then if I carry on and do that, so normal force is not 0. That's actually what I'm looking for. So it's this thing right here that's a question mark. You're going to solve for that guy. We know these things. We know everything on this side. We should be able to finish off and solve for this. So ... carry on and solve that.